Okay, take two. So, translations. That notation, capital T, the subscript, what do we call that? The vector, okay? Which means wherever we start, right? We're not starting at the order. It's not an order pair. It means wherever we start with a point, we move it which way? I would say over. To the right two, and then down to. Simple as that, right? And so they actually, oh, they didn't, did they? Where'd they go?
What?
Is this different?
Yeah. Oh, it's just
In my, you see your book?
your favorite book.
Why is that?
Maybe your book's different.
My book is different.
Are you on the wrong page?
We're on page 67, right?
No, 63.
Oh, it's the problem set. For the 63. I'm not very good at this. I lied on my resume to get this job. Okay. Well, it's still 2, -3, so that's what. All right, get your masks on. Go out the door to the right. So, as I was saying before that fire drill, we have a vector, which now I know why it's not on here because I was on the wrong page. Okay. So, remember this notation right here. Yep, do that. I know, just that right there. If you remember, that's equivalent to this. X comma y maps to x what? Plus what? 2 comma what?
-3.
Yeah. Right? They will do and accomplish the same thing. It's just different notations, right? Okay, so all we do then is take, let's take J. Which one? Over 2?
Yeah.
Down 2, 1, 2, 3. And here's our J prime, right? So I'm going to draw, well, I'll draw the paths in a minute, okay? So the same thing with K. 1, 2, 1, 2, 3. And here is K prime. And then H over 2, 1, 2, 3. H prime. Now let's talk about, okay? Now let's talk about some of the properties of translations. These are important, okay? We just went right 2 down 3 4. Did I miscount? You think I did? You guys think I messed something up? I think it's okay. Let me draw in some of these paths here. Like from here to here, that was the vector that moved that one, right? That's the same vector that moved the K, and that vector for the H, right? What can you guys tell me about the length of each of those paths, those vectors? 2 things. Just be able, they're parallel. They're all parallel. So we put parallel marks in. They're all parallel to each other. And what else are they to each other? Congruent, right? Same length. They're there and there. But now, that wasn't the only things that are parallel and congruent, right? Let's take this segment, JK prime, or JK to JK prime. What can you tell me about them? They are also parallel, right? So I'm going to use double parallel marks, right? So don't say that these two are parallel, obviously, right? And what else are they? Congruent to one another. And could I do the same for any of the corresponding segments, right? Okay, I won't clutter it up too much. So you get the idea? When you do a translation, those paths, the vectors are parallel and congruent, and the corresponding side lengths are parallel and congruent. That's important, okay? All right, so let's go down here very quickly. So they want us to determine the translation rule from the preimage to the image, okay? So if we start at A at -4, 1, and go to A prime, and they want us to use mapping or coordinate notation first, right? So that's going to do something like this, X, and then comma, and then Y, like that, right? So she says X, like to get this X from -4 to 1, you said +3? Yep. And then Y from 1 to 3 is what? Everybody get that? So we looked at that and we got the notation. Now let's put it in vector notation. And then this should be a subscript here, by the way, but yeah, that's it. Now make sure, it's going to be hard to write it as a subscript, okay, the way they set it up here, but make sure you had the brackets, 3, 2. Does that make sense to everybody? I know it doesn't look like the way they set it up, but that, when you do it without that, you make it a tiny little subscript, all right? Okay. How about the second one there? We go from A to A prime there. So it would be XY maps to what? X 7 to 3 minus 4, is that what you said? Sometimes it's hard to hear you. And Y minus 1. And over here, pointy brackets, what? Negative 4, negative 1. Okay? Not too bad, is it? All right, so down here, they've given us the translation, the mapping notation, and the pre-image point. They want us to generate the other one, right? The image point. So if the rule is xy maps to x minus 6, x minus 1, A prime will be fine. Negative 1, yeah, negative 7, comma, and then I lost my place, 2 minus 1 and 1. Okay? You guys do part B. Tell me what you got. Just apply the rule. What's it going to be? Everybody agreed? It'll be 3, comma, 4. Okay? All right, let's be careful on this next one. We're going backwards, right? Here's where it ended up after this rule, right? Okay? So where would you, so the rule is just x, we're not doing anything to the original x value, right? Okay, so the x, okay. So we subtracted 4 from something and ended up at negative 5. We subtracted it from negative 1. Okay, you guys seem like maybe you're a little better at arithmetic than last year's group. Okay? All right. Oh, now we're at vector notation. Right? So we take the x, subtract 1, take the y, subtract 2. Where does A prime end up at? 8, comma, negative 7. So notice, right, we've got pointy brackets for vectors, smooth brackets for parentheses for coordinate pairs. Right, coordinate pairs. Okay, I think we get the rest of that, right? So let's move on for time's sake. We'll take a look. Read over number 4. Looks like we're going to do 2 translations. See what they're asking there? So they want to do 2 translations, but they want to write it as just 1 translation. What do you think?
X minus 7, y plus 4.
He says x minus 7, y plus 4. What do you guys think? I'm not sure.
Wait, so you.
X minus what?
Yeah, X minus 10.
X minus 10. What did you do?
I just forgot.
Well, no, I meant you knew what you were doing. You said the wrong. But how did you get? So what did you took the negative 3 and negative, combined them, didn't you? Negative 3 minus 7 gave you a negative 10, and then you took the y part of it. 5 minus 1 is right. So the cumulative result is you moved it down, or you moved it left 10 and up 4. Does that make sense? So the rule would be x, y. Put the whole rule in here, right? Maps to, we said x minus 10, comma, y plus 4. Okay? With the other notation, it looked like what? T subscript what, comma, what? Negative 10, comma, 4. See how it's down in the subscript real nice there?
Oh,
Okay? They didn't say to write it like this, but I wanted to do both. Okay? That's not too bad. Those would be simple. And there's a couple of quick, easy little Regis questions. Let's look at them. Okay? Read that first one over. What do you guys think?
4.
He says choice 4. Which one would, important word, not carry it onto itself? So 4 would be a reflection over the perpendicular bisector. of one side. Let's draw a perpendicular bisector. But to reflect it, it's going to keep going, right? Perpendicular, bisector, middle. Wouldn't that map it onto itself? Like this side would go over here, the other one would go back over, it'd be the same thing. Okay, so get B4. What do you guys think? Remember, it's not. 2, 90-degree clockwise rotation about its center. It's a square. That's why it's important that if it was a rectangle, right? Okay. Choice 1, reflection over one of its diagonals. It's a square. So yeah, remember the number of reflection lines we'll have? That's one of them. 180 about one of its vertices. Okay, let's say that's a vertices in plural for vertex, right? Okay. 180, it'd end up over here somewhere. It definitely not mapped onto itself. Okay?
Oh, wait.
All right. Let's take a look at number 2. The second part's going to be a reflection over the line y equals 0. Y equals 0. What axis does it cut? The y. Where does it cut it? Is there another name for the line y equals 0?
X-axis.
It's the x-axis, isn't it? The line y equals 0 is just the x-axis. Do you see that? Let me ask you this. What would be another name for the line x equals 0? Yeah, there you go. Okay. So take a minute. Plot. Right to 5, right. Okay. So. 5. Whoops, that's correct. I forgot the up part. It's easy to do. Forget the up part. 1, 2, 3, 4. 1, 2, 3, 4, 5, up 2. Be here. And that's up. That. So does your first one at least look like what I have there? When I first did it, I made this common mistake. Somebody might have done it. I just did the right 5 and started plotting it. I forgot the up 2. That's easy to do. Okay? Correct yourself. Pay attention. All right. Go ahead and do the second part if you haven't done that. That reflection in what amounts to the x-axis. You know
So
what?
is it just going to do it?
Every point is the same distance on the other side of the line. You just count till you get the line and same distance to the other side. That's it. So 1, 2, 3, 1, 2, 3. There. And that's 1, 2, 3, 4. So this is double prime, and notice I got it labeled. Everybody, so how many have
This is over the y. Yeah, y.
over the line y equals 0, which we already established was what?
Oh, so
Remember, y equals 0. What axis does it cut through? Cuts through the y. Where? It's 0. Hey, that's the x-axis.
so for the one that we just drew over the x-axis, can we just follow the one that we just drew?
Yeah. So this is the first transformation, the translation.
So it's supposed to be.
And then from there, we reflect it. We take that and reflect it
Oh,
down. Okay?
yeah.
All right, get the idea? All right. One more to look at on the next page. Finish that up. There we go. As you're looking at the diagram they gave you, do you notice anything in here that tells you something? Double prime. What does that tell you? That they put something with double primes in there. That there's something in the in-between, right? Okay? All right. What do we think happened here? Yeah, go ahead. Okay, so they reflected it like over what line? So we reflected this way?
No, y 0 and x 0. The origin.
Yeah,
Okay, so we can't reflect over a single point.
over y equals x.
So that would be this line right here.
Yeah.
Or do you mean this y equals negative x?
That, that.
Now, be careful. What changes when you do a reflection? The what? Orientation. Let's see, what's the, so M-A-T-H, which way am I reading it here in the original? Okay, how about here, which way am I reading it?
No, clockwise.
Same. So what does that tell you? Can it be, could a reflection be involved?
No.
Unless it's two reflections and it's flip back, right, but there's not. Okay, so it can be a reflection, what? Okay, she's thinking rotation 180. What would be the center of rotation?
H.
Okay, which happens to be at the what?
Here.
The 0, 0 origin. Yeah, I think it's a rotate. So let's rotate this 180, right? So that's about the origin, right? So H is the invariant point. The special point stays there, right? And then we end up with, let's see, M would be, let's see, it's 1, 2, 3, 4, 1, 2. So what do we do? 1, 2, 3, 4, 1, 2, like there. Did I get that right? Up, down, right, left. Yeah, okay. So that's tricky. That's why I like to show you that other trick, right? And then then T, so they're going right, 1, 2, 3, 4, up 2. We're going to go left, 1, 2, 3, 4, down 2, like that. And then A ends up here. I think that's got it. Whoop, like that. So that's A single prime. This is M single prime, and here we have T single prime, and then equals H. Does that make sense?
Yeah. You do.
So rotation 180 about the origin, then how do we get to its final resting place? Translation, what?
2 left, 1 up.
I might have gotten something off there. I think I got something off there.
No.
I did. Something's not right. I got my A wrong, A prime wrong, didn't I? Yes, I did. I got my A prime wrong. Sorry. See, these could be a little tricky. Okay. So let me try that again. Yeah, so A prime is here. There we go. Say it happens to the best of us. A prime. Now it's more consistent, okay?
Left, 1 up.
Left one, up one, right? Okay, so so the two things. So we're going to say it's a rotation of how many degrees?
180 degrees.
Mm-hmm. Does 180 matter clockwise, counterclockwise?
No.
No. But we have to say about what? About the origin. I got to have that. Then what? You said it was a translation. Mm-hmm. Left 1, up 1. Notice I didn't use the notation for that, right? You can do either way. I wrote it out so you can see the difference. So that's acceptable on the readings, right? Or if you did the notation correctly, that's also acceptable, right? So just know both, okay? All right then. So we are going to, in the problem set, let's get this right. So for the problem set, we're going to do the top 3 of number 1. Top 3.
So which one are they?
Which one is what? Yeah, and problem number 1, there's 3 of them at the top. Right. Okay? Then you're going to do 2, 3, 4A through D, 5, 7, A and B, 8 and 9. Okay? Sounds like a lot.